We'll proceed in vector and commercial calculus. Vector and commercial calculus. In that sense, we are talking about flux calculus. Flux calculus. If I have a velocity and velocity is passing through area, then what is the net volume that is passing the area? Hop. If I have a velocity, consider there is a liquid stream. There is a liquid stream. Consider there is a big liquid stream is passing through. And then I am placing one ring inside the stream. How much liquid is passing through this ring? Okay. So that is called flux. For this surface, what is the flux? This surface and this velocity. Or, or consider there is a pipe. Consider there is a pipe through which a liquid is passing through. Take a cross section, make a cross section in the pipe, and this is the cross section in the pipe, and see how much is the volume of liquid that is coming from here per second. Calculate the velocity of the liquid, calculate the area, multiply it. Velocity into area is the net flux, net throughput that is coming out of the surface, and that is called flux. Understandable. So this is we are calculating. What is special about your flux? It is simple, right? Velocity into area is flux. But sometimes velocity may not be exactly in the direction of this hole. This, if this is the surface, then perpendicular to this surface is the surface vector. Surface vector is like this. If surface is like this, surface vector is like this. If surface is like this, surface vector is like this. If surface is like this, surface vector is like this. Surface vector is perpendicular to the surface. So if this is the surface, surface vector is like this. And this is the velocity vector. If velocity vector and surface vector, they are in same direction, then net flux is velocity into flux, or velocity vector dot area vector is the net flux. If velocity vector is like this, then there is nothing will come out from here, because velocity vector dot product with the area vector. Velocity vector magnitude, area vector magnitude cos theta angle between them. If theta is 90, then it is 0. Otherwise, cos theta between them. What? Why you are bringing into calculus, calculus commercialization? We are bringing in because this velocity vector may not be always straight. Okay, and the surface vector may not always be straight. Makes sense? Velocity vector may changing here and there. It may be algebraic vector, and surface may be changing here and there. It may be surface vector. Surface vector and velocity vector may be algebraic. Then this will become an abstract notation that velocity vector dot surface area vector is the net flux. Now it is abstract. It is not concrete, because velocity vector earlier it was in I, j and k, some number I plus some number j plus some number k. That is the direction of velocity vector. Like 2I plus 3j plus 4k. That is the velocity vector. What is your surface area vector? 5I plus 3j plus half k. That is my surface area vector. Both are static vector. All right. Surface is oriented in some fashion. Velocity oriented. But they are static. Velocity everywhere in same direction. Surface area vector everywhere it is in same direction. But if velocity vector is minus yi plus xj, okay, let's take 2D, minus yi plus xj, or minus yi plus xj plus x square k. So here the velocity vector is variable. Means every component is now in algebra now. Surface vector is also xi plus yj plus zk. Hope. Now, if velocity vector and surface area vector both are algebra, then how you calculate the flux? Then we will say again it is velocity vector dot of area vector. Velocity vector dot of area vector. But how you calculate area vector? Generally, area will be in algebra. From algebra, how you calculate velocity vector? From algebra, surface algebra, how you calculate the surface area vector? What are you talking about? One thing. Second thing is, if I have two multiplication and that is in algebra and there is dependent and independent there, then you cannot do direct multiplication. X into x is x square. But in calculus, x that is dependent upon other x, then x into x is x square by 2, not x square. That is calculus algebra. If one x is independent and one x is dependent upon the independent, then x into x is x square by 2. Mind it. If both are independent, then it is pure algebra. X into x is x square. Now, if I say that my velocity vector is minus yi plus xj plus zk, where z is dependent upon x and y. Z is not independent. Independent is only x and y. Similarly, area vector is also xi plus yj plus zk. Z is dependent upon x and y. If I have to multiply two items, this is multi-trillion dollar statement. Okay, if someone understands this, then artificial intelligence is his only. Means that is that straightforward. So if I am multiplying velocity vector with the area vector, and area vector is algebraic vector, velocity vector is algebraic vector, and there is independent and dependent algebra. Here also there is dependent and independent algebra. X and Y are independent, Z is dependent upon X and Y, or Z, that is vertical. This is X axis, this is Y axis, this is Z axis, that is vertical. If Z is vertical dependent upon X and Y axis, means dependent upon XY plane, then it is pure case of algebraic multiplication where dependency and independency is there. In that sense, we cannot do direct multiplication. It will fall in integral calculus scenario. Okay, can you summarize all together? I'm not able to understand. I'll summarize all together, don't worry. Okay, so I'll get back the surface again. Okay, so I'm getting back the surface again. Okay, so this is a sphere. Hope this is not a sphere. Consider this is a sphere. Now this sphere is centered at origin. The inner center of this sphere is kept at origin. This is x-axis, this is y-axis, this is z-axis. Now, in that sense, it is centered at the origin. Now, there is electric. This is example I am giving for past 3 times. There is electrical charge. There is an electrical charge that is kept at the center of this sphere. Electrical charge. If there is electrical charge, then there is a electrical field around it. Consider this is a liquid. Liquid is flowing from a center point all around. There is a liquid. How much liquid is passing, coming out of this surface? This spherical surface, how much is the liquid that is coming out of this spherical surface? When charge is kept at the center, when electrical charge is kept at the center, and because of the electrical charge, electric field is flowing all around. Consider electric field is liquid, then how much electric field is coming out of this surface? Now, this what is equation of your electric field? Q is the charge, net charge. R vector is the R vector. This is the spherical coordinate system divided by R to the power 3. That is my electrical velocity. And what is your surface? Surface is a spherical surface. Okay, I don't know what is it. This is what I want to know. How much it is coming out of the spherical surface? Now, this looks very tedious question. How much is the electric field coming out of this spherical surface where electric charge is kept at the center? If that is the case, then it is velocity vector dot area vector is the net flux coming out of this surface. What is area vector? We don't know. We calculated in the last video. Whereas what is the electrical field that is flowing? That is Q. Q is the charge Q into R vector divided by R to the power 3. If I talk in Cartesian coordinate system, then Q into AXI plus YJ plus ZK divided by x square plus y square plus z square to the power 3 by 2. Q charge Q xi plus yj plus zk divided by x square plus y square plus z square in denominator by 3 by 2. That is the that is the that is the velocity vector. If that is the velocity vector, what is area vector? Because net flux that is coming out is velocity vector dot area vector. Okay, area vector I don't know. Okay, now we'll calculate area vector. Now what we have learned from the previous session is if I have a position vector, what is the curve vector? Hope. We have exactly talked this in last video, but here we will do something that is more digestible. Okay, same thing we will prove in a more digestible way. If someone cracks this, full artificial intelligence is under his whatever knee or whatever someone can say, under his umbrella, under his control. How to calculate area vector? Now, if I see two-dimensional curve, this is a curve. How to calculate curve vector? What is curve vector? If this is the curve, then curve vector will be along this. If there is a line, consider that is a vector. But since line is curving, it is rotating, so this vector cannot rotate. Vector is a straight line. Then everywhere vector is different and it is tangent at that point. That is the vector representation of this displacement. If this is the displacement we are seeing, then this is the vector. What is it? Please watch previous videos that what we are going to say now. Now consider this is centered at the origin and there is any point P out here. That point is x comma y. From center, if I draw a line that is position vector, that position vector will be xi plus yj. What is your position vector? Xi plus yj is the position vector. If I differentiate this position vector at this point P, it becomes a tangent vector. Differentiation of position vector is tangent vector. This tangent vector is dp, derivative of p. P is position vector. D of xi plus yj is the tangent vector at point P. Okay, what is your dp? D of xi plus yj, dxi plus dyj, dxi plus dyj. That is my dp. Differentiation of position vector is the displacement vector or tangent vector. Similarly, if I am trying to calculate area vector, okay, velocity vector that is qr vector by r to the power 3 dot product with the area vector is the net flux. What is the area vector? Now at the center of this and consider any point P here. Any point P here, draw a line. Now that is the position vector. What is your position vector? That point is x comma y comma z. P point is x comma y comma z. What is the net flux? Velocity vector dot area vector. Area vector. What is line integral? How much is the energy that item is? I showed a two dimension, right? If an item is moving in this curve from here to here because of one force field, how much is the energy that is released by force field? That item moved because of the force field from here to here. Force dot distance vector, force dot displacement vector, or force dot d of position vector, because d of position vector is displacement vector. Similarly, if I have to calculate the flux out here, then it is velocity vector dot area vector. Area at point P. Okay, full area, I mean. Okay, full area. Okay, now velocity vector dot area vector instead of area vector at point P, I say now velocity vector dot d of position vector. Same. The way I did in two dimension, same thing. Velocity vector dot d of position vector is the net net flux coming out of it. When it is d of position vector, you have to place integration and integration over two independent components x and y. Now consider this is xy plane. This is xy plane, and you see the blue mark at the center. I believe it should be visible. Blue mark at the center. This blue mark, consider that is origin. Now this is oh, I'm now inserting it, and this is centered at the origin. Half up, half is up, and half is down. Okay. Now in that scenario, what is the what limit? If I calculate integration, what is the limit? If half is up and half is down, then limit falls in the independent component. Independent component is xy plane. Okay, this is x-axis, this is y-axis, this is z-axis. Limit is falling on xy plane. In that sense, limit will be a circle region. If I insert it, then on xy plane, it will make a circle. That circle is the limit. The circle limit on xy plane velocity vector dot d of position vector, where from the origin or center of it, any point I take P here and draw a vector that is xi plus yj plus zk. Now differentiation of that vector will become area vector. Differentiation in the circle of position vector become displacement vector. Similarly, differentiation of position vector will become area vector at point P. Since it is algebra, you keep changing x and y on the xy plane, keep changing x and y coordinate that will hit different point on the surface. Okay. If if this is centered at the origin and it is like this is the xy plane, if keep changing x and y on the xy plane, similarly z will change and it will represent all the point on the on this kind of on this surface. What is the equation of this surface? Algebraic equation. X square plus y square plus z square equal to a square. That is the radius of the sphere. Anyway, we learned now. Integration over a circular region on xy plane. Velocity vector dot d of position vector. In last video, we talked about d of position vector is same as d of position vector by d of xy plane into d of xy plane. And d of position vector by d of xy plane, we proved it is same as dp by dx cross dp by dy into dxy plane. This is how we proceeded. Now we will proceed in little bit kind of trivial fashion, because many people they understand through trivial way only. Okay, in that sense, now what is trivial way? dp, differentiation of position vector. What is dp? What is derivative of p? Then it will become, if p is xi plus yj plus zk, then it becomes dxi plus dyj plus dzk, where z is function over x and y, fxy, dfxyk. Okay, now let's proceed on it. So what it is? What is change in position vector? What is differentiation? What is dy by dx? What is differentiation? I am saying d of p, derivative of position vector. This is $1 trillion question. Now we are landing up into vector and calculus. Both are very powerful, extremely powerful. What is derivative of position vector? That is the question. What is derivative of y? What is dy by dx? If I have a this is 5 kg minimum. Okay, consider this is x-axis and I have a curve on top of x-axis. If this proof is not available anywhere else, please to support us. +91 is the India country code. 9483160610 is the telephone number. 9483160610 is the telephone number. +91 is the India country code. Now, if this is x-axis, consider there is a curve on it. This is y-axis, this is x-axis. There is a curve on it. Now, at any point x. At any point x on the x-axis, what is y? Function over x. Now if I move 1 unit from x, what is new height? What is difference in the height we see at point x when we move 1 unit? That is dy by dx. Or if I take any point x here, what is y? What is the height? No. Now go delta x from x. Now go delta x from x. This is x. Then new point is x plus delta x. If I move delta x from x, then how much height is moving? What is difference in height that is seen when I move, when I take 2 points? One point is x and one point is x plus delta x. At x, height is function over x. At point x plus delta x, height is function over x plus delta x. What is difference between these 2 points? This difference in the height came because I made a difference in x. Okay, how much is the height difference? That is delta y. How much is the x difference? That is delta x. Because of delta x difference, height difference came as delta y. If I see delta y by delta x, then because of 1 unit difference, how much delta y will change? That is delta y by delta x. Because of delta y, because of delta x change in x, how much y change? Delta y. Answer is simple, delta y. Because of 1 unit change, how much y would change? Then delta y by delta x. So at any point x, if I say dy by dx, per unit change in x brings how many unit change in y? I can simply say dy, 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 dy by dx means per unit change in x-axis brings how many unit change in y? Now we are talking about dp, derivative of position vector. Derivative of position vector means at point x. What is point x? Now this is xy plane. If this is xy plane, then this is the this is the surface. Now this is centered at the origin. I'm lifting it. Okay, okay. And this is xy plane. Then at any point x and y, there is a height. Now consider. I'm taking point P here, and this is xy plane. P is at height. This height is z. If I see on the xy plane, it will match one x comma y point. Or someone can say x0, y0. If I take another point here and go and see from the top on the xy plane, it will match another point called x1, y1. Similarly, for each x and y, it will touch one point on the surface. Okay. Now, if that is the case, if that is the case, now at point position vector P, if I look down, then it will point on xy plane, it will touch a point that is called x comma y. Full P is x comma y comma function over x and y. X comma y z. X comma y comma z. Now that is P. What is dP? If I am talking about x comma y, let's move delta x. No, I have to move both because x and y both are independent. This is $1 trillion answer what we have proved what I'm going to give now. It is not available anywhere else. Now consider there is a now the point P. Now point P on the surface, it is matching a point x and y here. Consider x and point here. Now from this point, you take delta x along x-axis and then you take delta y along y-axis. Now there will be another point called x plus delta x and y plus delta y. Now there are 2 points. One point is x comma y and other point is x plus delta x comma y plus delta y. Now at x comma y, I have position vector z. Position vector is x comma y comma z. Xi plus yj plus zk. Make sense? Now, if I move delta in x and y independent component, then there is another point there that is x plus delta x comma y plus delta y plus fx plus delta fx plus fx plus delta x comma y plus delta y function over x and y. That is the new point. What is these two position vectors? One position vector is xi plus yj plus zk. Another is x plus delta xi plus y plus delta yj plus fx plus delta x comma y plus delta y minus, I'm sorry, the p vector, the position vector p is xi plus yj plus zk. Then another p, because of the delta change, is another p. I say p1, that is x plus delta xi plus y plus delta yj plus fx plus delta x comma y plus delta y bracket close k. If I talk about dp, change in p, d derivative of p or change in p, change in p, dp means change in p, more or less. Change in p, dp. How much dp I am seeing here? Now, p1 minus p, anyone would say, okay, I have a point x comma y and I have a point called x plus delta x comma y plus delta y. One point going and meeting on the surface as P1, one point going and meeting as surface P. Okay, now if I want to calculate derivative of P, then P1 minus P, P1 minus P divided by whatever the distance we have taken in delta x delta y, that will be derivative of P. Make sense? But here, if I directly say P1 minus P, again I am saying it is not available any of the book. Okay, now consider that this is point P and this is new point P1. If I take P1 minus P, P vector and P1 vector, okay, if I differentiate these two, then it will talk about a straight line that is connecting P and P1. This is what I don't want, because this will again, it will give a two-dimensional curve only. I want surface area. I want differentiation in surface area. I want a name that is called surface area, not line. I don't want P1 minus P. Okay, what are you trying to show me? You tell me. I'm not able to understand what are you doing. What I am trying to say is, what is dp? D of position vector. What is derivative of p? Okay, if I in two dimensional, if I say dp, if there is a position vector dp, then I can write dp by dx into dx. Same thing, dp I can write as dp by dx into dx. Change in position vector because of change in x, dp by dx, that is the derivative. Dp by dx is the derivative because x is only independent component. Now here, if I have a position vector P, if I have a position vector P, then how much P would change if there is a change in area in xy plane? Hop. That is the derivative. We are trying to calculate surface derivative. Mind it, surface derivative means at P there is a surface here. Similarly, on xy plane, not x-axis or y-axis, here independent component is xy plane, not x-axis and y-axis. On xy plane, if I take two-dimensional region, then that two-dimensional region I can take as rectangle, delta x, delta y. Okay, but if I take two-dimensional area on the surface, it will be a surface. It won't be a rectangle. It will be a curve like thing. What are you talking about? Okay, if I take derivative in single independent component, if this is x-axis, this is y-axis. If I'm trying to calculate derivative, then I see if I move delta x along x-axis, then how much y is changing. Make sense? Here, here, here delta x is the independent component and y is dependent component. Or dp by dx, if I move delta x along x-axis, how much position vector is changing? If you see the energy calculation, force vector dot d of position vector, because I know d of position vector is the displacement vector. D of position vector, I can write dp by dx into dx because dx. I know that there is only one independent component x. So if I change one unit along x-axis, how much position vector is changing? That is dp by dx. Here, position vector is representing area and independent component is represented by xy plane. Now I write dp instead of dp, I am writing dp by dxy plane into dxy plane. But explanation will be different than what the past one. Now what are you talking? What is dp by dxy plane into dxy plane? dxy plane. dxy plane. If I change dx one unit of area, dp by dx one unit of length, if I change along x-axis, how much position vector is changing? That is dp by dx. dy by dx, if I change one unit of length along x-axis, how much y is changing? dy by dx. dp by dx. Here, independent component in xy plane. dp by dxy plane dot dxy plane. If I change one unit of area on xy plane, how many unit of area I change? How much unit, how much position vector is changing? Okay, net flux is velocity vector dot d of position vector of surface. dp is same as dp by dxy plane into dxy plane. dp by dxy means if I make one unit of area change in xy plane, how many unit of area change, how much change I see in the position vector dp by dxy plane. Now I'll go back again. Now in the xy plane, I had taken a kind of consider I have taken one point x comma y, and there I change x as delta x, I change y as delta y. Now there is another point x plus delta x comma y plus delta y. How much change in the area I am seeing now? Delta x into delta y. There is a new rectangle came in. From x comma y, I proceeded in delta area. In two dimensions from point x, I proceeded delta x. New point is x plus delta x. And there I see change in the position vector, that is dp by dx. Okay. I gave example with the y. Take, take position vector. Now here I have a point x comma y. I take another point on the surface, that is x plus delta x comma y plus delta y. I moved in area fashion. If there is a delta area change in xy plane, the delta, what is your delta area change? Delta area change is delta x into delta y or dxy plane, dx dy. So dp by dxy plane is nothing but if there is a delta x delta y change in the xy plane, correspondingly, how much position vector would change? dp by dxy plane. If there is a delta x and delta y area change on the xy plane, how much position vector would change? dp, how much position vector would change? How much position vector is changing? When a point is x comma y, then position vector is p, that is xi plus yj plus zk. When there is another point that is x plus delta x comma y plus delta y, then there is a new position vector, that is x plus delta xi plus y plus delta yj plus fx plus delta x comma y plus delta yk. Now there are two position vectors. If position vector change because I am changing the point from x comma y to new point in area fashion, x plus delta x comma y plus delta y. Per unit change in area brings how many unit change in the surface position vector, that is dp by dxy plane into dxy plane. Okay, now if I am seeing the change in position vector directly, I cannot subtract. If one is p and one is p1, then p1 minus p will not give the change in the position vector because we want change as area, not as a curve. If it was a curve, then I could have said p1 minus p1 minus p divided by dx. Now here divided by dx dy is true, but p1 minus p I cannot take in a straightforward manner. Straightforward manner means delta x. It will be delta xi plus delta yj and plus fx plus delta x minus comma y plus delta y minus whatever it is. I cannot take in this fashion because this is a straight line. I have to see change in the surface area vector because there is change in in the xy plane at delta x delta y. What it will be? Okay, then it will be one position vector. Now let's see the surface. Okay, consider this is the surface. What surface I was showing? This is the surface. This is point P and this is point P1. This is point P x comma y comma z, and this is new point, that is x plus delta x comma y plus delta y plus z plus delta z, or fx plus delta x comma y plus delta y. Now these are 2 points. This is P and this is another vector P1. Now I'm trying to calculate change in area position vector. In that fashion, now there are two vectors that comes into the picture. One vector is along the x-axis and one vector is along the y-axis. Along x-axis, if I take change, means one change that happening because of delta x, one change is happening because of delta y. Now on the xy plane, take 2 points. One point is x comma y comma z. Another point is x plus delta x comma y comma z. I'm sorry, one is x comma y. Another point is x plus delta x comma y. This is along x-axis. Take another line, that is one point is x comma y, another point is x comma y plus delta y. That will go up and it will match here. Now, if this is point P, if this is point P and this is point P1, then this line, now this is the diagonal line. Now, if I take this line along y-axis, then if this is x comma y comma z, then this point will be x comma y plus delta y comma z plus delta z, or fx or fx comma y plus delta y. Now, if I move along x-axis, this is the new point. That is this point is x plus delta x comma y plus fx plus delta x comma y. Okay, this is fx comma y plus delta y. This is fx plus delta x comma y. Now, this displacement and this vector, if I take diagonal, then this point is x plus delta x comma y plus delta y comma z plus delta z, for which x coordinate, x component is x plus delta x comma y comma z plus delta z, or fx plus delta x comma y. Y component is x comma y plus delta y comma fx comma y plus delta y. Now this is one vector, this is another vector. If I take cross product of these two vectors, then this will be P2 vector. Okay, what is this vector? What is this vector? Make sense? What is this vector? One is xi plus yj plus zk. Another is x plus delta x comma y comma mu z. If I subtract to get the one vector, then it will become delta xi y gone. Delta xi plus fx plus delta x comma y minus fxyk. Okay, there are two vectors. If from origin, if I connect this, then this point is position vector p. This point is position vector p1, and they arisen because this point p is x comma y comma z. The p1 point is x plus delta x comma y plus delta y comma fx plus delta x comma y plus delta yk. These 2 points correspond to on xy plane point x comma y and another point x plus delta x comma y plus delta y. Now I made a change in the xy plane at delta x and delta y. I made I made a change because since xy plane is flat, this region is rectangular region, delta x delta y. What is the area you change? Area I change is delta x into delta y. Because of area change delta x and delta y, how much surface is changing, or how much position surface vector is changing. Position surface vector will change if this P2 and P1, P2 minus P1 is a tangential vector at surface at that point. For this tangential vector, I take x component, I take y component. If I do cross product, what is the change we are seeing? Change is actually P1 minus P, P1 minus P. That is the tangential vector. Hope, hope, hope. Makes sense? If this is P1 and this is P, that is xi plus yj plus zk, and this is P1, that is x plus delta I plus y plus delta j plus fx plus delta x comma y plus delta yk. Now, how much is the change I see as far as position vector is concerned? P1 minus P. That P1 minus P, that will be tangential vector at this point. Okay, this tangential vector has x component and y component. If you do cross product of these two, then actually you see the change in the area, that you see change in delta x and delta y, that is happening on the surface side, because it is two dimension. What is the horizontal component? Horizontal component of P1, if you see the horizontal component, if point P and P1 is there, the horizontal component, this point is x plus delta x comma y comma fx plus delta x comma y y. Okay, and vertical component is x comma y plus delta y comma fx comma y plus delta y. If I calculate this vector and this vector and take cross product, makes sense? Okay, anyway, so one vector will become delta xi plus fx plus delta x comma y minus fxy. Another will become delta yj plus fx comma y plus delta y minus fxyk. Makes sense? That is the change in that is the change in position vector. Cross product of these two. How much change in the position vector you are seeing? Anyone would ask. Because there is a change in delta x, delta y along the x in the xy plane. In the z plane, the surface plane is triggered by xy plane through a function. If at point x comma y on the xy plane there is a position vector xi plus yj plus zk, where z is function over x and y, there is a change I am making delta x and delta y, because the two dimension both I have to change. There is a new point now, x plus delta x comma y plus delta y. Corresponding to that point, I have another point called P1, x plus delta x comma y plus delta y comma fx plus delta x comma y plus delta y. Okay, now I'm trying to calculate, because of the area change I'm making in xy plane at delta x, delta y, how much position vector would change as area. Position vector, how much it change, and P1 minus P directly you can say. That is delta x, delta y, and delta z, simply. But as far as area change is concerned, if there is area change on xy plane at delta x into delta y, how much position vector as an area it would change on the surface. Then position vector, whatever we are seeing, P and P1, its x component, P1 and P, its y component. You do cross product, that is the net area that is changing, because there is a delta x, delta y change along the xy plane. How much that is? That is, one is delta xi plus fx plus delta x comma y minus fxyk. One, cross product with delta yj plus fx comma y plus delta y minus fxyk. If I do cross product of these two vectors, then surface area vector I am getting. How much is the change because of delta x, delta y? You have to divide it by delta x, delta y. Now, first one would become I plus fx plus delta x comma y minus fxy by delta x. So, I vector. I would, I would say it again. The two vector I am getting as cross product, which correspond to the change in the area on the surface. One vector is delta xi plus fx plus delta x comma y minus fxyk. Cross product, another vector is delta yj plus fx comma y plus delta y minus fxyk. Now let's divide it by delta x, delta y. Delta x, because I want to see the change. I want to see this area full. Cross product means change in the area. change in the area because there is a delta x delta y change, because I want per unit change. That is actually dp by dxy plane. Okay, so if I do that, then I have to divide by delta x delta y. Now the first term cross second term. First term, let's divide by delta x cross second term divide by delta y, because after all it's multiplication. So delta x first side, delta y second side. So first side is delta xi plus fx plus delta x comma y minus fxy k divided by delta x. That will become I plus fx plus delta x comma y minus fxy k divided by delta x. Fx plus delta x comma y minus fxy by delta x. This is typical differentiation of dp by dx. I'm sorry, fx plus delta x comma y minus fxy delta x is typical differentiation of dfxy by dx. That is better term, dz by dx. So it becomes I vector plus dz by dx k vector. Cross product j vector plus dz by dy k vector. I plus dz by dx k cross product j plus dz by dy k. This is this is what we are talking about dp by dxy plane. For dp by dxy plane, if there is one unit change in xy plane, how much position surface vector would change into dxy plane? This is what we have given. Now it net area vector becomes dxy plane I dxy plane I plus dxy plane into dz by dx k cross product dxy plane j plus dxy plane into dz by dy k vector. This is full area vector. Now velocity vector dot product with dx dy, dxy plane is dx dy, dx dy I plus dx dy into dz by dxk cross dx dyj plus dx dy dz by dyk. Settle it down, full become now integrand and differential. If someone settle it down, it become velocity vector dot product with the minus dz by dxi minus dz by dyj plus k in bracket dx dy. That is full area vector minus dz by dxi or minus dx dy dz by dxi minus dx dy dz by dyj plus dx dyk. That is the area vector. Someone has to do dot product with the velocity vector. Okay, so velocity vector is q xi plus yj plus zk divided by x square plus y square plus z square to the power 3 by 2 dot product with minus dz by dxi minus dz by dyj plus k dx dy. If someone settle it down, q I can take outside. Okay, it becomes minus x by x square plus y square plus z square power 3 by 2 3 by 2 dz by dx minus y by x square plus y square plus z square to the power 3 by 2 dz by dy. Okay, plus z by x square plus y square plus z square to power 3 by 2 3 by 2 dx dy. Okay, if someone, what is dz by dx? Z is square root of a square minus x square minus y square. Dz by dx is minus xy square root of a square minus x square. Similarly, dz by dy is minus y square root of a square minus x square minus y square. And k term is z by x square plus y square plus z square by 3 by 2. If you completely settle down this statement, then it becomes a square by x square plus y square plus z square to the power 3 by 2 into square root of a square minus x square. Because square root of a square minus x square, a square minus x square, that square root of a square minus x square minus y square, and by 1 by square root. So last term does not have a square root of a square minus x square minus y square. Someone can try it. So this is what is the net calculation. I believe in the past video we tried it. So it first term it becomes minus x square by x square plus y square plus z square. That is a square. X square plus y square plus z square. That is a square as per sphere, knowingly, unknowingly. Then a square, a square, a square, I can take it out completely. 1 by a square, I can take it out completely. Now it becomes minus x square by square root of a square minus x square minus y square, minus y square by square root of a square minus x square minus y square, plus z by nothing. Z is the square root of a square minus x square minus y square. If someone settle down, then numerator will become a square and denominator will become square root of a square minus x square minus y square. A square and a square gone. Nothing. Only q is outside. Now integration of 1 by square root of a square minus x square minus y square dx dy. Now circle over which we are integrating it is circular region where x is minus a to a and y is minus a square root of a square minus x square to a square root of a square minus x square. Now anyway, let's consider y. I am doing different way. Let's consider y equal to square root of a square minus x square cos theta. Y equal to. Then dy equal to square root of a square minus x square minus sine theta d theta. If you replace there, then dy will become minus square root of a square minus x square sine theta d theta. Okay, dx will remain, and divide by square root of a square minus x square minus y square. A square minus x square and y square will become a square minus x square cos theta. Take out the square root of a square minus x square, it becomes 1 square root of 1 minus cos square theta, sine theta. So numerator is minus square root of a square minus x square sine theta, and denominator is square root of a square minus x square sine theta. Full will go away, minus will remain there. Minus you can keep outside. Q is anyway outside, minus q. Now d theta integration is theta. Now y equal to square root of a square minus x square cos theta. Theta is cos inverse of y by square root of a square minus x square. Now where y is square root of a square minus x square, then x is cos inverse 1, that is pi by 2, minus then minus pi by 2, pi. So integration is pi. Integration of 1 by square root of a square minus x square minus y square dy, it turned into pi. Simple pi. Pi dx. Pi I can keep outside and it becomes dx. dx. Now dx integration minus a to a. 2a. If I leave minus right now, it becomes 2a. It become, okay, I'm sorry, it becomes 2a minus a to a. It becomes 2a. This is what I think so. 2a. So it becomes pi to a, something like that, and q outside. Okay, this is what I think so. So I'll try again. So 1 by a square root of a square and a square gone. Okay, 1 by a square root of a square minus x square minus y square. Okay, let's do it in spherical coordinate, in polar coordinate system. If I do in polar coordinate system, dx dy will become r d theta dr as per the Jacobian. Okay, I am in little bit hurry. So r by square root of a square minus r square. X is r cos theta and y is r sin theta. Then r by square root of a square minus r square. Okay, dr d theta. If I do integration of r by square root of a square minus r square, it will become minus 1 by 2 square root of, sorry, it will become minus 2 square root of a square minus r square. If I differentiate minus 2 square root of a square minus r square, then it will become minus 2r divided by square root. So it will be same. So all right. Minus 2 square root of a square minus r square is the integration. Radius is from 0 to a. A if I put, then it becomes 0. And if I put 0, then it becomes a. Minus will go away. A. Integration is a. A d theta 2 pi a. There also I was getting 2 pi a only. So 2 pi a. Net flux is 2 pi a. Now if I am calculating for that upper half only, because I place the sphere sphere I place the sphere in xy plane, and we are calculating for the xy. So xy I had taken in a kind of upper part only. So multiply by 2. 4 pi a. 4 pi a cube will be the net flux. Okay, we will do better calculation. I'll try again. Okay, so in the next step, so this is how we calculate the kind of flux, velocity vector dot d of position vector, whatever it comes. If it is Cartesian coordinate, then it comes as minus dz by dxi minus dz by dyj plus k dx dy, integration over the region on the xy plane. I tried to do again, but this is how it is. Please do support us. Plus 91 is the India country code. Country code 9483160610 is the telephone number. 9483160610 is the telephone number. Plus 91 is the India country.